Hello everyone, my name is Mohammed. I am a software engineer, and today we are going to discuss how to build a data-driven application. So first of all, it would be great if you have a basic knowledge about programming in general, and if you know what data types are or the differences between data files extensions. And if you don't, it's okay. I will try to explain everything clearly. So as you can see, this is the overview of the workflow in general. So the first step will be data loading. We will collect data from multiple files. After that, we will apply some data preprocessing techniques. And right after that, we will perform some data analytics on this data and play around with the data so we can understand the nature of it. Right after that, we are going to build a model to try to predict the future behavior of some attribute. And eventually, we will build an interactive interface so the user can use this application. So, as I said, the dataset, the main dataset, will be created using two different sources. The first one is a CSV file, and it contains, as you can see, the larger part of the dataset, and we will use another dataset or another file to augment this data. Here, as you can see, a JSON file. Both of these files contain or have the same attributes here. So it is going to be easy to uh, merge both of them. So here, these are the libraries that we are going to use. And as I said, the first step is going to be loading the data. So as I said, we have two data files. The first one is a CSV data file, so we need to find the path at first. Here, data CSV file, and the other one is a JSON data file, so we'll take path as well, data and JSON. Here we are. We are going to use Pandas to load these files. So CSV file will be like pd read CSV CSV. Here we go, and we will do the same for JSON. Here, JSON, and there we go. To concatenate this data, we are going to put them together in a list like that. If equal to CSV file and JSON file. Right after that, we will apply the concat method on them. So df will be like pandas.concat df like that. To take a look at the preview, we need to run this first. We need to select an environment. I have already created a virtual environment to isolate the dependencies of this application, and you can do the same. It is a good practice. So we have to select like that. Here we go. As you can see, we have 25 columns. Actually, we are not going to need all of these columns, so we are going to drop few columns like that. The same df or data frame, we will drop few columns from it. The columns will be, I will just copy paste them from here. These are the columns. So we'll come back here. I think we're good to go. Yeah, we are good to go. df. As you can see now, we have only 14 columns. One last thing to do before moving to the next step, we need to check if there are any empty values. So we will do it simply by counting the null values and gathering them together. like that. Null count will be df dot is null summation null count. Here we are. So as you can see, we have no empty values in these columns, and this is great news, you know what I'm saying? Before proceeding, it is better to have a look at the dataset. So as you can see, we have a large dataset, and there is a date, order date column, yeah, order date column. These are the values of this column. As you can see, it contains date values, but it needs to be pre-processed. So we will remove this part, the zeros part, and the white space in the middle. And actually, we are going to use the white space to split this whole value and take the first part, which is this one. Before moving to the analytics step, we need to perform one last preprocessing operation by creating a new column that we will use later, and we are going to call it year month. Here we'll run all, and we'll see the results. Yeah, everything is good. Now the next step will be a simple analytics operation. As you can see here, we have different countries here, USA, France, Spain, and so on. So these countries are the origin countries of the clients, and we will group by these countries to take a look at the total sales of each country, and simply we will do that by applying the group by method. So we will create a variable here. Let's call it country aggregated data. Use the data frame group by method, and we are going to group by the country. After that, we'll apply the aggregation method here. We'll create a new column for this aggregation group, and we'll call it total sales. It will be created by gathering all the sales using the sum function. Another column will be created. It's called client counts. We are going to count the number of clients in each country. So customer name, we are going to use the count function here, and eventually we are going to sort this group, sort values using these sort values. There we go. We will sort it by the total sales value. Total sales value. And we are defining the order. The larger will be listed first. So now we can print it and take a look at the results. There we go. We have the total sales of each country. As we can see, the USA have the highest amount of sales, and we can save that by creating new variables. maybe like highest countries. Let's call this variable highest countries to get the countries that have the highest amount of sales. So that's it. Total sales, and eventually take the head, the top three, and let's take the lowest countries as well to make it a comprehensive analytic by country total sales, and maybe head. Nope, not it. Not going to work. Maybe like -3 to take the lowest three. Let's print them. Control V, take the lowest as well. Sorry, the lowest. There we go. As you can see, the highest countries are USA, Spain, and France. The lowest countries are Belgium, Philippines, and Ireland. Here I will copy paste a code block to visualize the results from here. As I said, these code blocks does not affect the core logic directly. A visualization here. USA has the highest share, and as you can see here, Ireland has the smallest. The next operation might be calculating the total sales for each month, and we will do that by targeting the month ID column. That's it. It has 12 values, and each value represents a month of the year. And by doing that, we will take a comprehensive look at the total sales of each month. We will pretty much do the same here, so we can copy this code. So yeah, can run it. Yeah. See, take a look at the results. Here we go. And we can visualize it as well by using this code. Yeah, as you can see, the 11th month has the highest amount of sales, and after it comes the 10th or October, May, and so on. Moving to the next operation, maybe for the next operation, we are going to use this column that we created earlier. Instead of collecting the total sales based on the month, we are going to use the month in a specific year. So let's go, we have a timeline of 2 years. We are going to calculate the total sales of each month in each year. And by doing, you will understand what I am trying to explain. Group by year, month, and we can call it maybe monthly sales. We don't need to sort it, doesn't really matter here. So monthly sales for each month in each year, as you can see here. Right after that, you are going to visualize it so you can take a better idea. Here we go. As you can see, this is the total timeline of our dataset. Again, you can see that the 11th month has the highest amount of sales, Yeah, that's it. Going back to the dataset, as you can see here, we have a column called product code. Each product has a unique code, so we can use these values to create a new analytics where we calculate the total sales of each product, and by that we can figure out the most selling products. And to do that, we might create a variable name product products performance, maybe more accurate, performance tf dot group by again. Let's click run all. Here we go. So as you can see, this product right here has the highest amount of sales, and here we see the lowest selling product. Next, we are going to use the deal size column. Here, as you can see, it has three values. It is a categorical column that has three types of values: small, medium, and large. Yes. So based on that, we will see which kind of deal size is dominant in each country. So it is straightforward. Things hard. We are just going to uh, create a cross tabulation between the country column and the values of deal size, and by that we will create a ready to use data frame. So deal size, maybe using pandas dot cross tabulation, we use the country column, and we are going to use the deal size column as well. Deal, here we go. Here we have to reset the index to be able to access the country column. Okay, great. So as you can see, here we have Australia. Australia has 7 large orders and 86 medium-sized orders and 92 small-sized orders. And it is, as you can see, has the data of all the countries. As you can see, the green represents the small-sized orders, the yellow one represents the medium-sized orders, and the red represents the large-sized orders. Next, we will try to get the most favorite product in each country. Have large, medium, and small. We'll get the most frequent value. $40 in countries classified. So here you can see that we have classified the countries based on the most frequent deal size. The large sized orders were not dominant in any countries, and that makes sense. Now we will proceed to get the most popular product in each country. So we will do like countries. For that, we will create a repo for the popular product. Here we go. Now for country, in countries, So we have created a dictionary of data frames where we grouped by the total sales of each product in each country. I know this is a little bit complicated, but this is required for getting the target information. The top 5 products, maybe 5, yeah, of each data frame or of each product data frame will be like product df. Here we'll create a list called filtered list. Right after that, for product in the top 5 products, we'll get the product name, and we'll do that by targeting the product name column df. Again, we'll reset the index here, and finally the last line will be printing the most popular product in each country. Filter list. Below here we can see for example, most popular product in Philippines is classic cars, most popular product in Germany is planes, and so on. The next step will be working on trends, and the definition of trend is pretty much the performance of a specific attribute over the timeline. And to start working on this step, we have some utilities that I have already wrote. We need them to proceed, and in a minute I will explain how they work. So, trend assessment algorithm. Before we start, we need to introduce some concepts. They are easy to understand, but anyways, as you know, each year or the year in general has 12 months, and for that our timeline have more than 2 years, almost like 30 months or something like that. And to assess the trend, to evaluate it, whether it is doing good or doing bad, we want to do the following. For each month, we will count a 12 month ahead, so we will compare it with the same month as in the next year. So for example, we have the first month here, we will compare it with the first month of the next year, and if possible, we will compare both of them with the same month of the next year. So, for example, we'll take the first month here. The first month in 2003 have a specific value here. Let's call it y1. Let's call this point y1, and this one is the image of the first month of 2004, and let's call it y2, and here this green point represents the y, or the image of the first month in 2005. So by comparing them, we can see that the performance is rising, is getting better. And let's take more examples. Here I think the 9th month, yes, exactly, we are comparing it with the next 9th month, or the 9th month next year. As you can see, the values are almost the same, so we can call this performance stable, and so on with the other months. So after collecting these informations, we come here, we do the same process over all the months, and eventually we will get 12 results. As you can see, the first conversion here, the result of it is rising, unstable, rising, and so on. After that, we will take the most frequent value and we will generalize it, or we will select it to be the result of assessment, trend assessment overall. So if there are too many good comparison, that means that the performance overall is good. And that's exactly what I am going to do next. We are going to apply the same algorithm on both sales and maybe products, and we will see. To apply this idea on the sales performance trend for each country, we can do it simply by collecting all the year month values by targeting the year month dot unique. We'll get the unique values. After that, we need to get the unique countries, and it will be country dot unique as well. Eventually, we need to get the count of the countries. Here, I need to copy paste the trend logic. It is a bit complex and it does not have a direct impact on the core logic, so it is okay to copy paste it here. And countries, everything is set. Exactly. Now it is going to generate the visualizations. For each country, we can see the sales performance over the timeline. So as you can see, this is the USA. We can take it to a new tab. Here, the USA, Norway, Finland, and so on. We can see some similarities between some countries. For example, here in Norway and USA, Finland, UK, the performance is similar. But the Switzerland, for example, it has a weird performance. Maybe it is not even predictable, but the other ones might be predictable. So because, for example, in USA, in the 11th month, you can see that there is rising in the total sales. And here as well in Australia, for example. So these are predictable. Let's move to the next trend assessment, which is the sales performance trend for each product. But there's a little problem here. We have like maybe more than 100 products, so we will not be able to visualize the trends of all the products. We are going maybe to visualize only one example, but I will assess trends in a automatic way to get the best value of the data. I'm just going to copy paste the code here. So this code is designed to collect all the sales data or total sales data of each product over the timeline. And by that, we created here a product's performance record, which will contain all the sub data frames where each data frame represents a single product. So as you can see, we have huge amount of data here. If we click on scrollable elements here, as you can see, all of these are data frames that are going to be used next. For example, we're going to visualize a single trend. Here we go. This is a random product. We are showing here the performance over time. So, for example, in the first month, this product was not sold at all, and later it got better in the second month, and so on. Now I am going to use the logic that I have just explained. We are going to apply it by using these functions that I have already showed here. Yes, this one are going to be used. I am going to analyze all the products trains. Let's just ignore these warnings. Come here. Now we are good to go. As you can see, the results are the number of rising products are 73, and this is a good result. Now we are going to work on the forecasting model training. We are going to use the profit model. It was developed by Facebook, and it is great for forecasting tasks. So first of all, as you can see here, we define the training data. We only selected few columns. The sales column will be the target column. The order date will be the index column, and the quantity order will be used later to support the training process. Now, before proceeding, we grouped the sales and quantity or orders quantity based on the order date. After that, we renamed the index. Here we defined the split date, which is almost takes the last 20% of the dataset to use it for testing. Here we are defining the train and test subsets. Right after that, we are setting some configurations that the model requires. For example, the model expects some column to be named in a specific way. So the DS or the date columns in general should be renamed to DS, and the target value or the target column should be renamed to Y, as you can see here. Right after that, here I am using the orders quantity to support the model training. So it is not the target. We are not trying to predict the order quantity. We are just using it to get better results. Here we are defining the model or the model object. Right after that, we added this regressor. They call it regressor, which is some data columns or data structures that helps the model to get more accurate results. Here we are training the result the model. Right after that, we are doing the same here for the test subset. We are setting the required configurations. Right after that, we used the p-model test subset to test the model by passing it as an argument to the predict method. Right after that, we are going to print the forecasting results and compare it with the actual data. And here we are going eventually to visualize the results. So let's run all and see what's going to happen. It's going to take a few seconds. So let's start cell by cell. Here we are, as we said, preparing training data. Here we train the model. It took less than 1 second. Here we are setting the required configurations. These are the results. Here, as you can see, for example, these 5 rows are the actual data, and these 5 rows are the predicted data. And you can compare it and see that they are similar. For example, here, the first row with the first row, the difference is not big, and you can do the same with the second rows. As you can see, the differences are small, which means the performance overall was good. Here we are visualizing the results. As you can see, the lines are very close, and the confidence margin, as you can see here, is in green. So the actual sales or the actual data is visualized using this blue line, and the forecasted sales are visualized using the green lines. So Now we can move to the last step. Our last step is the UI. I have built this application. It contains the exact same core logic that we just discussed, but with a little bit slightly different syntax. I have used Streamlit framework to create a web application. So we are going to run this application by entering the command streamlit run by. Here, as you can see, we have our application, our Streamlit UI. Here on the sidebar, we have some stats. We can close it for now. Here we have the same visualizations that we have created already. And below here, we have the sales forecasting results visualizations. And that's it. This is our video, and you can access the source code and the application from the description section below. Thank you for watching.